Extreme motorsport is not Formula 1 or NASCAR. There are boats hitting 200 miles per hour on water, powered by the same insane turbine engines that lift 50,000-pound military helicopters into combat zones. This is the real extreme. H1 Unlimited Hydroplane Racing features 30-foot missiles skimming across lakes, throwing 300-foot roostertails 6 stories high. All thanks to screaming turbines that changed everything. The turbine revolution wasn't inevitable. It was a brutal technical war where jet engines had to dominate so completely they killed off an entire era of racing. The undisputed champion of modern hydroplane racing, the Lycoming T55 L7, powers the CH-47 Chinook helicopter and has dominated unlimited racing since the early 1980s. This turboshaft monster weighs just 830 pounds, yet churns out 3,000 horsepower with current restrictions. Compare that to NASCAR's 670 horsepower from 575 pounds. The turbine makes over 4 times the power while weighing just 50% more. The engineering is brilliant. A 7-stage axial flow compressor combines with a single-stage centrifugal compressor, squeezing air to extreme pressures. Compressed air mixes with Jet A fuel in a reverse flow combustion chamber, spinning a 2-stage gas producer turbine plus a separate 2-stage free power turbine that's mechanically independent, driving the propeller through reduction gearbox. This separation is genius for hydroplanes. When the propeller exits water during turns, the power turbine adjusts independently without causing the gas producer to surge. A piston engine would self-destruct. Here's the controversy. The T55 GA714A in modern Chinooks makes 4,867 shaft horsepower. But racing rules restrict these to 3,000 horsepower. These boats aren't running anywhere near true potential. Fuel consumption is astronomical, 40 to 50 gallons per 5-minute heat. Hey, quick timeout here. If you're enjoying this deep dive into these insane turbine engines, do me a solid and smash that subscribe button. Hit that bell icon too, because we've got more crazy content coming your way. Trust me, the story gets even wilder from here. Alright, let's keep rolling. The T53 doesn't get enough respect. Bucket List Racing runs this in their U440 boat, creating a different story from the T55. The T53 originally powered the legendary Bell UH-1 Huey helicopter. If you've watched Vietnam War movies, you've heard that distinctive whomp, whomp, whomp. Weighing just 688 pounds, it's 142 pounds lighter than the T55. The T53L13 produces 1,400 shaft horsepower, while the later T53L703 bumps that to 1,800 horsepower, anywhere from less than half to roughly 60% of T55 output, making these boats definite underdogs. What makes this compelling? Kelly Stocklin and Bucket List Racing chose this engine to promote more economical unlimited racing. Running a T53 significantly reduces fuel consumption, maintenance costs, and financial barriers. It's like showing up to a Formula 1 in a Formula 3 car. The T53 uses a 5-stage axial compressor followed by single-stage centrifugal compressor. Overall pressure ratio is around 7.2 to 1, compared to over 9 to 1 on the T55. Remarkably, Bucket List Racing has won heats against T55-powered boats, despite giving up potentially 1,200 horsepower. In 2023, their U40 set the 5th fastest qualifying speed in history at 171.294 miles per hour, absolutely mental considering the power disadvantage. Seattle businessman Jim Clapp's U-95, built in 1973, was the first turbine-powered hydroplane, proving jets could compete with pistons. This was a $250,000 gamble on unlimited racing's future. The U-95 used twin Lycoming T55 engines identical to Huey helicopters. Each weighed 500 pounds and generated 1,700 horsepower, for a combined 3,400 horsepower. The two turbines turned a single propeller shaft through a special gearbox, reportedly costing $250,000 alone, over $1.7 million today. Designer Ron Jones created a futuristic three-tailed speedster looking more spacecraft than boat. This was truly the first rear-engined unlimited hydroplane, even featuring provisions for spoilers never tried before. The U-95 debuted in 1974 at Miami, becoming the first turbine starting in competition. The finest moment came at Tri-Cities, where driver Leif Borgerson beat George Henley's piston-powered pack, averaging 113.469 miles per hour to Henley's 113.071. Tragically, the career ended at the 1974 Gold Cup in Seattle, when the boat blew one T-53 and sank. Borgerson was unhurt, but owner Clapp had died earlier that year. The hull was sold and re-engined with Allison piston power. The U-95 didn't win championships, but proved the concept, paving the way for the turbine revolution. 6 years after the U-95 sank, Dynamite Dave Herensperger tried turbine power with a different approach. The 1980 pack became the first unlimited, using a single Lycoming T55 engine, establishing the configuration becoming the sport's standard. Designer Jim Lucero and Dave's pilot Dixon Smith chose a single T55. The same 2,200 horsepower Chinook helicopter engine weighing 600 pounds. Single-engine configuration was simpler, lighter, and more reliable than synchronizing two turbines. The pack's first appearance at 1980 Tri-Cities was catastrophic, yet spectacular. During Sunday morning test runs, rookie driver John Walters pushed throttle, and the boat became airborne, executing 2.5 complete 360-degree flips before the judges' stand before crashing into water. Walters survived with minor injuries. The violent flip revealed fundamental problems. Turbine smooth power delivery combined with lighter weight meant these boats generated lift more easily than piston hulls. Designers hadn't accounted for aerodynamic forces. After modifications, pack returned in 1981, showing speed but struggling with consistency. In 1982 at Seneca Falls, New York, the turbine pack finally won, becoming the first turbine winning since U-95 8 years earlier. Herensperger earned distinction as first owner winning with turbine power, establishing the single T55 template virtually every team uses today. If pack showed turbines could win, the 1984 Atlas van line showed they could dominate so thoroughly that piston engines would never win another championship. This boat launched the turbine revolution, changing unlimited racing forever. Designed by Jim Lucero and Dixon Smith, the Turbine Atlas debuted in 1984 with Chip Hananauer driving, using a single Lycoming T55 L7, producing approximately 2,800 horsepower. The turbine's reliability and consistent power delivery gave Hanauer a weapon competitors couldn't match. The competition debut at Indiana Governor's Cup on July 29, 1984 was revolutionary. Hanauer obliterated competition and every record, qualifying record at 135.034 miles per hour, single lap record at 129.328 miles per hour, 5-lap heat record at 122.822 miles per hour. Winning margins were absurd. 53.7 seconds in one heat, 34.35 seconds in the final. At the 1984 Gold Cup at Tri-Cities, Hanauer set a one-lap record of 137.762 miles per hour, the fastest competition lap ever run at that time. Unlimited Racer Commissioner Don Jones called it a new era. Atlas Van Lines became the first turbine winning the Gold Cup. The 1984 Atlas launched Hanauer on an unprecedented streak, winning 6 consecutive Gold Cups from 1984 to 1989. By decade's end, turbines had completely displaced piston power. This boat didn't just win, it killed an entire era. Alright, we're about halfway through. If this video is scratching that motorsports itch in you, go ahead and hit that like button. And drop a comment below telling me what you think. Now, let's get into some of the more experimental and controversial turbine applications. Before diving into legendary pistons dominating for decades, let's discuss fundamental differences and why this transition was controversial. Turbines run on Jet A fuel, essentially kerosene, stable, widely available, relatively safe compared to exotic racing fuels pistons required. Piston engines run on everything from aviation gasoline to methanol to exotic cocktails mixed with nitrous oxide and alcohol injection. Some teams ran liquid explosives. Power delivery is completely different. Turbines produce smooth, linear power, no vibration, no reciprocating mass, just continuous rotational energy. Piston engines produce violent, reciprocating power pulses. 12 cylinders firing means 12 power pulses per revolution times thousands of RPM. Weight tells stories. A T55 turbine weighs 830 pounds, fitting in spaces not much larger than beer kegs. An Allison V1710 weighs 1,650 pounds and is 86 inches long, over 7 feet. The Merlin adds another 250 pounds. Here's the controversial part. Those old pistons, built by the best builders, could produce more power than modern restricted turbines. Modified Allisons with turbocharging and exotic internals reportedly produced over 4,000 horsepower. Griffons in Miss Budweiser's heyday made similar numbers. Modern T55s are restricted to 3,000 horsepower. Why did turbines win? Reliability. Race all season with routine maintenance versus piston rebuilds after 1 hour. Cost and availability. Surplus WW2 engines became scarce, while Vietnam-era turbines flooded markets. Insurance and safety. Spectacular piston failures were increasingly dangerous. The Allison V1710 was a 1,710 cubic inch liquid-cooled V12 powering World War II fighters like the P-38 Lightning, P-40 Warhawk, and early P-51 Mustangs. When surplus Allisons hit markets after war, boat racers saw potential. Miss Golden Gate 3 in 1946 was first racing with an Allison, setting a competition lap record of 77.9 miles per hour at Detroit's Gold Cup, mind-blowing for 1946. The Allison overpowered the 26.5-foot hull so badly Arena could barely control it. What made it special? Bulletproof design with 4 valves per cylinder, overhead camshafts, and modular construction. The 60-degree V-angle with 5.5-inch bore by 6-inch stroke created huge displacement in compact packages. The most desirable racing variant was the G-Series, specifically V1710 G6R and G6L models. A batch of 750 engines originally intended for P-82 twin Mustangs were surplused in the 1950s, becoming Unlimited Racing's foundation for decades. Racers modified with increased compression, aftermarket turbochargers, alcohol injection, and exotic fuels. Some builders coaxed over 4,000 horsepower from Allisons running at 4,000 RPM. Insane considering original design speed was half that. Mind-blowing detail. These required complete overhauls after 1 hour of racing. After 60 minutes cumulative runtime, entire engines came apart with every component inspected and often replaced. The Rolls-Royce Merlin won the Battle of Britain, powered the P-51 Mustang to become World War II's finest fighter escort, then absolutely dominated unlimited hydroplane racing for 3 decades. This engine changed everything. The Merlin displaced 1,650 cubic inches with 5.4-inch bore and 6-inch stroke in a 60-degree V12. Built by Rolls-Royce in Britain and under license by Packard in America, the Packard V1650 versions became most sought after because of improvements in later variants. What separated Merlin from Allison was supercharging. While Allison's relied on external turbochargers, Merlin's used integrated 2-stage, 2-speed superchargers that were compact, efficient, incredibly effective. That technology translated directly to racing performance. The Packard V1659 became the gold standard. In racing trim, these ran at 4,200 RPM, double design speed, with gearbox ratios around 3:1, spinning propeller shafts over 12,000 RPM. The Merlin's dominance is unbelievable. From 1960 to 1979, Merlin-powered boats won 19 out of 20 national championships and 17 out of 20 Gold Cups. That's complete obliteration. Slow Motion 5 became first, winning a Gold Cup with Merlin Power in 1954. After that, Miss Thriftway, Hawaii Kai 3, Miss Century 21, Miss Bardol, Miss Budweiser, and Atlas Van Lines all relied on Merlin Power during championship runs, setting records and making Allison competitors look slow. The Rolls-Royce Griffon was a 2,240 cubic inch monster, 36% larger than the Merlin. Developed starting in 1938 as a scaled-up Merlin for British naval aircraft needing maximum low-altitude power, the bore and stroke of 6 inches by 6.6 inches came directly from legendary Schneider Trophy racing seaplanes. Despite being 30% larger than the Merlin, it was only slightly bigger physically because Rolls-Royce moved camshaft drives and magneto to the front. The engine used hollow crankshaft for lubrication, a significant improvement, and featured single high-efficiency dual magneto atop propeller reduction casing. Only 3 unlimited teams used Griffon power. Gordon Thompson's Super Test team with Miss Super Test 2 and 3 from 1954 to 1961. And later Miss Budweiser. Racing variants were typically Mark 74 with 2-stage, 2-speed superchargers, featuring ratios of 5.16 in medium speed and 6.79 in full speed mode. Miss Budweiser's 1980s Griffon program pushed to absurd power levels. By modifying crankshaft lubrication and bearings, they increased peak RPM to 4,000, producing piston speeds of 4,400 feet per minute, pistons traveling nearly 50 miles per hour up and down 33 times per second, with high-octane racing fuel, alcohol injection, and nitrous oxide. Brake mean effective pressure exceeded 360 pounds per square inch, power output exceeding 4,000 horsepower from a late 1930s design. The 1980 Miss Budweiser dominated so thoroughly it changed the sport. In 1966, Kentucky contractor Bill Sterrett did something the establishment thought impossible. He built a boat powered by 2 supercharged Chrysler 426 Hemi V8 engines, and not only competed against Allison and Merlin boats, but won races. Miss Chrysler Crew became the only automotive-powered hydroplane ever winning a major unlimited race. The twin Hemis, built by legendary Keith Black, each produced approximately 1,000 horsepower for combined 2,000 horsepower, significantly less than the 2,500 to 3,000 horsepower aircraft engines made. But Sterrett had tricks. The boat was smaller and lighter at 29 feet 2 inches and 6,000 pounds versus typical 30 to 35 feet and 7,000 pounds. The two 426 cubic inch Hemis mounted in tandem connected to a special Casale-designed gearbox. The entire power plant weighed 1,672 pounds, considerably less than single Allison or Merlin installations. At the UIM World Championship race in Detroit on July 2, 1967, Miss Chrysler crew made history. Days before, the team discovered a magic formula for carburation, giving Hemis additional revolutions and power. Sterrett drove through rough water, terrifying other drivers, winning all 3 heats with perfect 1,200-point score. Fastest lap, 104.046 miles per hour. The victory sent shockwaves, proving automotive engines could beat aircraft engines, dominating since 1946. Unfortunately, Chrysler dropped sponsorship after 1967, citing costs maintaining 6 Hemi engines. If the Hemi story was improbable, the Ford attempt was quixotic. In 1976, California machine shop owner Walter Knudsen debuted U-14 Miss O'Neill and Knudsen powered by twin Ford 427 cubic inch SOHC engines, the Cammer. Built by Indianapolis builder Louis Sonny Meyer Jr., they ran methanol fuel with fuel injection. The Ford 427 SOHC was exotic even by exotic standards. Ford developed the Cammer in 1964 to dominate NASCAR and drag racing. Single overhead cam per bank, hemispherical combustion chambers, could rev to the moon. NASCAR promptly banned it as too powerful, making it more desirable to racers. Knudsen's boat used cab-over design with driver ahead of engines. The twin Fords running methanol with electronic fuel injection produced impressive dyno numbers. Overhead cam design allowed extremely high RPM, and methanol permitted aggressive timing. Unfortunately, Miss O'Neill and Knudsen never achieved success. The boat struggled with handling, and Ford engines didn't produce low-end torque needed for hydroplane racing. Engines were designed for straight-line acceleration, not constant loading and unloading hydroplane propellers experience. After limited competition, the boat converted to conventional aircraft engine power like other automotive attempts. The Ford experiment proved what insiders knew: automotive engines couldn't match unique characteristics making aircraft engines successful. Massive displacement, broad torque curves, and proven reliability of Allisons and Merlins were perfectly suited to hydroplane demands. There you have it, the most insane turbine engines ever built for unlimited hydroplane racing. The modern T55 L7 producing restricted 3,000 horsepower, the scrappy underdog T53, the pioneering U95 twin turbines that proved jets could compete, the trend-setting pay-and-pack that survived spectacular crashes to establish the single turbine standard, and the game-changing 1984 Atlas van lines that dominated so completely it ended the piston era overnight. These screaming jet engines transformed hydroplane racing from temperamental piston monsters into reliable aerospace marvels. Sure, we covered the legendary pistons too. The Allisons, Merlins, and Griffons were incredible, but they were the old guard that turbines had to conquer, and conquer they did, bringing military helicopter technology to water and creating the most spectacular racing on Earth. If this deep dive got your adrenaline pumping, smash that subscribe button. Thanks for watching, and remember, life's too short to drive boring stuff, or race boring boats with boring engines. Go big or go home.